And here we go. We're in Chapter 9. We're going to talk about polar coordinates and polar equations. We've been living our life in the XY plane for most of your mathematical career. Now we're going to drop ourselves in the polar plane. Usually a polar graph looks like that, and you have a radius and an angle. And instead of an XY coordinate, you have an R theta coordinate. So that's to say if you were going to go a radius, a positive radius would go to the right, a negative would go to the left. A positive angle would go counterclockwise, just like you learned in trig class, and a negative would go clockwise. So let's just plot a point, say the point 2, 45. So the radius is 2, go to the right 2, and then you go up 45. There you go, there's the 2, 45. What about negative 3, pi over 2? Go to the left, negative 3, and then I'd go counterclockwise, 90 degrees. That would put me down there. And then negative 3, negative 220 puts you in the fourth quadrant. Every polar coordinate can be written 4 different ways. So I give you an example here. Let's just go out radius 3 up 60. I could also write that with a positive 3 radius, but go negative 300 all the way around. I could go negative 3 and then positive 240. I could go negative 3 and then sneak in the back door and go negative 120. All those are the exact same point. 4 different ways to write one point. If you were going to write an equation for a circle, it would only have a radius. Doesn't matter what the angle is. If the radius is always 2, then I'd go out to a radius of 2 and I'd draw a circle. If I was going to draw an equation of a line, that means it doesn't matter what the radius is. I just need to know the angle. The important thing is the angle extends all the way through. No matter what the radius is, my angle is always 120 degrees. You can find the distance between two polar coordinates using the formula, and you'll see it in the book in case you can't read some of my writing. And it looks big and ugly, and then you think, wonder where that thing comes from. And if you think about it a little bit, if you plotted 2 points and said, hey, I want to find the distance between the two, I really need to find using the law of cosines, I could easily do that. Now the last thing I'm going to let you look up in the book, so I'm hoping you brought it, because there's equations for 5 different polar equations that we want to learn. They're in the book. Look them up and look at those last 5 graphs I gave you.